Most people think aging starts with your skin, wrinkles, gray hair, lower testosterone, slower metabolism, maybe a little more stiffness when you get out of bed. But those are downstream effects. One of the more important changes begins somewhere you cannot see. Inside your cells, specifically inside the mitochondria, that produce the energy those cells need to stay alive. And here's the part almost nobody tells you. Your mitochondria are not permanent. They are constantly being damaged, repaired, recycled, removed, divided, and which means mitochondrial aging is not simply a one-way decline. You cannot reverse the number on your birth certificate, and no legitimate protocol can promise that. But mitochondrial function is remarkably adaptable. Old, inefficient mitochondria can be cleared. New mitochondria can be produced. Existing mitochondria can become better at generating energy. And some of the metabolic characteristics that deteriorate with age can move in the opposite direction when you send the right signals consistently. Not through one supplement, not through some $500 anti-aging stack, through a specific sequence of biological signals that your cells already know how to to. And the order matters, because if you're trying to build new mitochondria while continuing to damage the ones you already have, you're solving the wrong problem. So I'm going to walk you through the entire mitochondrial repair protocol step by step. What damages mitochondria? How your cells identify the damaged ones. How they remove them. How they build replacements. The exercise signal that appears to matter most. The role of muscle. What sleep is doing to this system. What eating pattern supports it. Which supplements are actually worth discussing. And at the end, I'm going to put everything into a 7-day schedule that you could realistically start next week. But before we build the protocol, there's something worth settling. Because it changes how you hear everything else in this video. Mitochondria are not just batteries. That's the analogy everybody uses. And it's incomplete. A battery stores energy. Mitochondria are closer to tiny power plants that are constantly sensing what is happening around them and changing their behavior in response. They take energy from carbohydrates and fats and use it to generate ATP, the molecule your cells spend to perform biological work, contracting muscle, maintaining electrical gradients in neurons, repairing tissue, moving molecules across cell membranes, building proteins. Almost everything your body does costs ATP, and mitochondria are responsible for producing most of it. But energy production has a cost. Any machine that processes fuel creates waste. Mitochondria are no different. As electrons move through the mitochondrial respiratory chain, some escape. That can generate reactive oxygen species. At normal levels, those molecules are not necessarily bad. They're signals. Exercise creates some of them, and that temporary stress is one of the reasons exercise makes you stronger. The problem is chronic excess. When mitochondrial damage accumulates faster than your cells can repair or remove it, the system starts becoming less efficient. The mitochondria produce energy less effectively. More damaging signals can escape. Inflammatory pathways become more active. Insulin sensitivity can deteriorate. Muscle function declines. Recovery gets slower. And because mitochondria exist in particularly high numbers in energy-demanding tissues like your brain, heart, and skeletal muscle, those tissues feel the consequences first. This is one reason mitochondrial dysfunction is considered one of the hallmarks associated with biological aging. But there's a second side to this. Your cells evolved an entire quality control system specifically to prevent this from happening. And that brings us to step 1. Step 1. Stop thinking about mitochondria as something you need to boost. You don't want more mitochondria indiscriminately. You want better mitochondria. That's different. Imagine a city with 1,000 power stations. Half are modern, efficient, and producing clean energy. The other half are 40 years old, barely functioning, leaking waste, and constantly requiring repairs. Building another 100 power stations doesn't solve the underlying problem. You first need quality control. Your cells do this through a process called mitophagy. Mitophagy is a specialized form of autophagy that targets mitochondria, Damaged mitochondria lose certain characteristics that healthy mitochondria maintain. One of the most important is their membrane potential. You can think of this as the electrical charge mitochondria need to run properly. When that electrical state collapses, proteins including pink-1 can begin accumulating on the mitochondrial surface. That helps recruit another protein called parkin, and together this signaling system helps mark dysfunctional mitochondria for disposal. The damaged mitochondrion gets isolated, broken down. Its useful components can be recycled, and the cell removes a source of dysfunction before it creates larger problems. This is mitochondrial quality control, and it becomes less efficient with age, which is why the first goal of mitochondrial repair isn't simply making more. It's improving the balance between removal and replacement. This distinction matters enormously. Mitophagy removes the broken equipment. Mitochondrial biogenesis builds the replacement equipment. You need both. And fortunately, there is one intervention that activates this entire remodeling system more reliably than almost anything else we know. Exercise. But not every type of exercise sends exactly the same mitochondrial signal. Which brings us to step 2. Step 2. Build your aerobic base before you chase intensity. If I had to choose one habit for improving mitochondrial function across the body, it would not be a supplement. It would be aerobic exercise, and specifically enough sustained aerobic work to repeatedly challenge your cell's ability to generate energy oxidatively. Here's what happens. When muscle contracts for an extended period, it burns ATP. ATP levels are constantly restored, but the changing energy state inside the muscle acts as a signal. One of the important sensors involved is AMPK. When cellular energy demand increases, AMPK activity rises. That signal interacts with another major regulator called PGC1 alpha. PGC1 alpha is sometimes described as a master regulator of mitochondrial biogenesis. It helps turn on the genetic machinery involved in building and maintaining mitochondria. More mitochondrial proteins get produced. More oxidative enzymes are expressed. The machinery responsible for burning fat becomes more capable. Capillary adaptations improve oxygen delivery, and over repeated training sessions, the muscle begins remodeling itself around the workload you keep asking it to perform. This is important. Your body doesn't build mitochondria because mitochondria are healthy. It builds them because you repeatedly create a reason to need them. Demand first, adaptation second. That's the sequence. And one of the easiest ways to create that demand without destroying your recovery, sustained moderate intensity aerobic work. People often call this zone 2. Don't get obsessed with the exact heart rate number. Heart rate formulas based purely on age are approximations. The practical version is simpler. You're working, your breathing is noticeably elevated. You can still speak in sentences, but nobody would mistake what you're doing for a relaxed walk. For some people, that's brisk uphill walking. For others, cycling, jogging, rowing, swimming, and elliptical. The modality matters less than maintaining enough continuous demand. Start with 30 minutes, 3 times per week. If you're currently sedentary, even that may be too much initially. Start with 15 or 20. Build toward roughly 40 to 60 minutes per session as your fitness improves. And here's how you know the mitochondrial adaptation is happening without ever seeing a mitochondrion. The same workload becomes easier. You walk the same hill at a lower heart rate. You cycle at the same heart rate, but produce more power. You move faster while breathing at the same rate. You recover sooner. This is your metabolic machinery becoming more capable. Not overnight. Across weeks. And this is where people make the first big mistake. They assume that if moderate exercise helps mitochondria, extremely hard exercise must help them more. Not exactly. Intensity is powerful, but intensity is a different signal, and it belongs later in the sequence. Step 3. Add a small dose of very hard. Once you have an aerobic base, high-intensity intervals become extraordinarily useful. Because during a hard interval, ATP demand rises much faster than your aerobics comfortably meet it. Your cells experience a much stronger energy disturbance. AMP rises. AMPK signaling increases. Calcium signaling changes. PGC1 alpha gets activated through multiple routes, and the adaptation signal can be disproportionately large relative to the amount of time you spend exercising. This is why interval training has produced impressive mitochondrial adaptations in human research, including in older adults. But here's what people misunderstand. The interval is not where you get better. The interval is the signal. Recovery is where the remodeling happens. If you turn every workout into a maximal workout, you keep sending stress without giving the system enough time to finish adapting to it. That's not mitochondrial optimization. That's just accumulating fatigue. For most people, one interval session per week is enough to begin. Eventually, maybe two. A simple version looks like this. Warm up for 10 minutes. Then perform 4 hard intervals lasting somewhere between 1 and 4 minutes. Recover fully enough between them that you can produce quality effort again. Then cool down. Hard means hard. You shouldn't be casually discussing your weekend plans during the interval. But this also does not mean collapsing on the floor. The goal is repeatable intensity, not self-destruction. If you're new to exercise, have cardiovascular disease uncontrolled, blood pressure, significant joint problems, or you've been sedentary for years, this is not where you start. Build the aerobic base first and talk with your clinician when appropriate. Again, sequence. Moderate aerobic work creates the foundation. Intervals amplify the signal. And then there's another piece that becomes increasingly important the older you get. Muscle. Step 4. Protect the tissue that contains the machinery. One of the strangest things about the anti-aging conversation is how much attention goes to exotic molecules and how little goes to skeletal muscle. Muscle is one of your largest metabolic organs. It stores glucose. It disposes of glucose after meals. It contains enormous numbers of mitochondria. It releases signaling molecules when it contracts. And it creates a metabolic reserve that becomes increasingly valuable with age. Starting in adulthood, people who don't actively protect muscle tend to lose it over time. The process accelerates later in life. Less muscle means less physical capacity, lower glucose disposal, lower reserve during illness, greater frailty risk, and fewer metabolically active fibers for your mitochondrial system to live inside. Think of muscle as the real estate. Your mitochondrial machinery operates inside that real estate. Losing the building while obsessing over upgrading the electrical system doesn't make much sense. So, resistance training belongs in the protocol. 2 to 3 sessions per week. You do not need to become a bodybuilder. You need to repeatedly ask your major muscle groups to produce meaningful force. Squats or leg presses, hip hinges, rows, presses, pulling movements, loaded carries. Whatever version fits your body and training experience. The exact exercise is less important than progressive overload. Your muscles need a reason not to disappear. If you can perform the same weight for the same repetitions forever without difficulty, your body has very little reason to adapt. Over time, increase something. Weight. Repetitions. Range of motion. Control. Total training volume. Not everything at once, something. And this is where the system starts becoming interesting. Aerobic exercise improves the oxidative machinery inside muscle. Strength training protects and expands the muscle available to contain that machinery. Intervals create a powerful metabolic stimulus. 3 different signals, same biological system. They don't compete when programmed intelligently. They stack. Before we go further, let me ask you something. Which one of these is currently missing from your week? Aerobic work strength training or genuinely hard effort? Drop the one you're missing in the comments. Because for most people, mitochondrial health isn't being limited by some obscure nutrient deficiency. It's being limited by one missing signal they haven't sent consistently in years. Now we need to talk about the period between workouts. Because you can train perfectly and still interfere with mitochondrial adaptation every night. Step 5. Protect the maintenance window. Sleep looks passive. Biologically, it isn't. While you're asleep, your nervous system changes state. Hormonal signaling changes. Temperature changes. Brain waste clearance processes change. Tissue repair occurs. Metabolic regulation resets. And your circadian system coordinates thousands of genes according to time of day. Mitochondria participate in that rhythm. Their activity is not identical at 10 in the morning and 2 in the morning. Energy metabolism is circadian. Insulin sensitivity is circadian. Body temperature is circadian. Hormonal output is circadian. And when sleep timing becomes chaotic, those systems lose part of their coordination. Here's the analogy. Imagine a factory that performs maintenance every night between midnight and 4 a.m. One night, the factory closes at 10. The next at 1:4. The next at 3. Then somebody runs the machinery until sunrise. The maintenance crew still exists, but you've made their schedule unpredictable. That is roughly what irregular sleep does to biological timing. The practical version is not complicated. Aim for a consistent wake time. That matters more than most people realize. Get outdoor light relatively soon after waking when possible. Morning light is one of the strongest signals your brain uses to set the circadian clock. Keep your sleep opportunity long enough to actually obtain the sleep you need. For most adults, that generally means somewhere around 7 to 9 hours. And protect the last part of the day from the things most likely to damage sleep. Bright light late at night. Alcohol. Large late meals if they disturb your sleep. And caffeine too late for your own metabolism. Coffee may contain interesting polyphenols, but a mitochondrial benefit in the morning does not compensate for destroying your night. That's a trade most people calculate incorrectly. Caffeine has a half-life measured in hours. If you're sensitive to it, your afternoon coffee may still be pharmacologically active when you're trying to sleep. So if sleep quality is poor, move caffeine earlier, before buying a sleep supplement. Fix the signal before adding another molecule. And now we get to nutrition. This is where mitochondrial advice becomes unnecessarily complicated. Ketogenic diets, fasting, carnivore diets, carbohydrate cycling, NMN, MCT oil, resveratrol. 20 different ways to make a basic biological principle sound impossible. The principle is much simpler. Step 6. Give your mitochondria different fuels to work with. Healthy mitochondria are metabolically flexible. That means your body can shift between using carbohydrate and fat depending on availability demand. After a carbohydrate-containing meal, glucose oxidation rises. Between meals, and during lower intensity activity, fat oxidation becomes more important. During hard exercise, carbohydrate becomes extremely useful because it can generate ATP rapidly. The problem is not that your mitochondria ever burn glucose. The problem is chronic metabolic inflexibility, a system that is constantly overfed, rarely challenged, rarely depleted, and increasingly resistant to insulin. This is one reason movement is so important. Muscle contraction creates glucose uptake through pathways that are partly independent of insulin. A simple walk after eating can meaningfully improve post-meal glucose handling. Nothing exotic. 10 or 15 minutes of movement. And here's another simple principle. Your mitochondria do not benefit from being surrounded by excess energy continuously. That does not mean everyone needs prolonged fasting. Human evidence does not support pretending we know an exact hour when every person's mitophagy suddenly switches on. We don't. But having a normal overnight period without continuous food intake is very different from eating from the moment you wake until 5 minutes before you sleep. A simple starting point for many healthy adults is approximately a 12-hour overnight eat. Dinner at 7:30, breakfast at 7:30. Nothing extreme. For some people, a slightly longer eating break fits naturally. For others, it doesn't. If you're pregnant, underweight, have a history of eating disorders, use glucose-lowering medication, or have medical conditions affected by meal timing fasting strategies, need individual medical guidance. The point isn't deprivation. The point is rhythm. Periods of feeding, periods without feeding, periods of work, periods of recovery. Your biology evolved around alternation. Modern life has a tendency to flatten all of those cycles, Food all day. Light all night. Sitting all day. Stimulation all night. Then we wonder why the system stops responding normally. For the food itself, you don't need a mitochondrial diet. You need a diet that supports metabolic health. Enough protein to maintain muscle. Vegetables, fruit, legumes, whole grains if you tolerate them, nuts and seeds, fish, unsaturated fats, foods rich in micronutrients, mostly minimally processed food, and enough total energy to support your activity without turning every meal into chronic excess. A Mediterranean-style pattern is a very reasonable template because it consistently performs well across cardiovascular and metabolic outcomes. Not because olive oil contains a magical anti-aging molecule, because the entire pattern works. This distinction matters. Nutrition works as a system. Now there's one more mitochondrial process worth understanding before I give you the actual weekly schedule. And it explains why recovery isn't weakness. The repair cycle, stress, recover, adapt. Your mitochondria respond to hormesis. A small temporary stress can trigger adaptations that leave the system more resilient afterward. Exercise is the cleanest example. During exercise, you create stress. ATP demand rises. Reactive oxygen species transiently rise. Calcium flux changes. Fuel stores fall. The cell senses disturbance. Then the workout ends, and your body responds by increasing its ability to handle that disturbance next time. More enzymes, better oxygen delivery, improved mitochondrial machinery, sometimes greater mitochondrial content. The stress itself wasn't the benefit. The adaptation to the stress was the benefit. That means more stress is not automatically better. If every day contains intense exercise, calorie restriction, severe sleep deprivation, sauna, cold exposure, psychological stress, and a job that keeps your nervous system activated until midnight, you have not created an anti-aging protocol. You've created an inability to recover. This is where the anti-aging world occasionally gets the biology backwards. They stack every hormetic stressor they can find. Hard training, fasting, cold plunges, heat, calorie restriction, supplements. Then they sleep 6 hours because apparently sleep is the only intervention not considered sufficiently advanced. Recovery is part of the protocol, not an interruption to it. So schedule easier days. Walk, sleep, eat adequately. Allow hard sessions to be hard and easy sessions to actually be easy. This is how adaptation compounds. And now we need to clear up the most expensive part of this conversation. Supplements. The mitochondrial supplement trap. If you've searched mitochondrial health online, you've probably seen the list. CoQ10, PQQ, NMN, NR, resveratrol, alpha-lipoic acid, acetyl L-carnitine, urolithin A, creatine, and dozens more. Some of these compounds have interesting research. Some have legitimate clinical uses. Some improve specific biomarkers. Some have promising mechanisms, but weak human outcome data. And some have been marketed several years ahead of the evidence. The mistake is treating all of them as replacements for the signals we've already covered. They aren't. Take NAD. NAD is essential for cellular metabolism and mitochondrial function. Levels can change with age. Precursors like nicotinamide riboside and NMN can increase NAD-related metabolite in humans. That's real. What has not been established is that taking an NAD precursor makes healthy humans biologically younger in any comprehensive clinical sense. Those are two very different claims. Biochemical target engagement is not the same as proven lifespan extension. Same with resveratrol. Fascinating molecule. Interesting animal and mechanistic work. Much less impressive evidence for dramatic anti-aging outcomes in humans. CoQ10 is biologically important, and supplementation may make sense in certain circumstances, but it does not replace aerobic conditioning. Creatine is probably one of the more practical supplements in this entire conversation because the Evidence for improving strength and lean mass-related outcomes is extensive. It also supports the phosphocreatine system your cells use to buffer rapid ATP demand. But even creatine doesn't repair damaged mitochondria by itself. It supports a system you're already training. That's the pattern I want you to notice. Supplements can modify the environment. Training provides the demand. Sleep provides recovery. Nutrition provides raw material. Mitophagy provides quality control. Biogenesis provides replacement. It's a system. And that brings us to the protocol. The 7-day mitochondrial repair protocol. Here's how I would organize this for a generally healthy adult who already has medical clearance to exercise. Monday, strength training. A full body session. Squat pattern. Push, pull, hip hinge, carry or core work. You do not need 20 exercises. 4 to 6 movements performed with effort is enough. Then, after meals, walk for 10 minutes when practical. Normal dinner. Then give yourself a normal overnight break from eating. Tuesday, Zone 2. Start with 30 to 45 minutes. Cycling brisk, incline walking, jogging, rowing, whatever lets you maintain continuous, moderate effort. You're not chasing exhaustion. You're accumulating mitochondrial demand. Wednesday, recovery. Walk, move, do normal life. No requirement to manufacture more stress. If you're experienced, this could be your second strength day instead. But if you're new, recovery is useful. Thursday, strength again. Same basic movement categories. You don't have to use identical exercises. Progress gradually. Friday, Zone 2 again. 30 to 60 minutes depending on your fitness. Saturday. This is where the interval session goes once you've built enough fitness to tolerate it. Warm up thoroughly. Perform a small number of hard intervals. Recover between them. Cool down. The session can be short. The signal doesn't require an hour of suffering. Sunday. Recovery. Walking. Light movement. Maybe mobility work if you enjoy it. Sleep. Prepare for the next week. That's the training skeleton. Now layer the daily signals on top. Wake at approximately the same time. Get outdoor light. Move throughout the day. Eat enough protein to support your muscle. Base most meals around minimally processed foods. Stop turning every hour into a feeding event. Walk after meals when possible. Put caffeine early enough that it doesn't interfere with sleep. And protect your sleep schedule. That's it. It sounds almost disappointingly simple, which is exactly why people ignore it. There's no bottle, no secret compound, no complicated morning ritual. The biology is sophisticated. The behavior is basic. And that distinction is probably one of the most important things in this entire video. What changes first? If you follow this consistently, don't expect to wake up on day 8 looking 10 years younger. That's not what mitochondrial adaptation looks like. The early changes are functional. In the first couple of weeks, you may notice that exercise stops feeling quite as expensive. Your breathing settles faster after a hill. Your recovery between sets improves. Your energy may feel more stable if better sleep and less constant grazing improve glucose regulation. Then performance begins to shift. The same aerobic pace produces a slightly lower heart rate. Or the same heart rate allows a slightly faster pace. Your strength improves. Walking feels easier. Those are measurable. And they're useful because mitochondrial function is not something most people can test directly at home. A laboratory can measure mitochondrial respiration from tissue. You probably aren't going to biopsy your quadriceps every Thursday to make sure the is working. So use functional proxies. Your aerobic capacity, your pace at a given heart rate, your strength, your resting heart rate, your blood pressure, your waist circumference if metabolic health is a goal, your glucose markers when medically appropriate, and perhaps most importantly, your VO2 max if you have access to reliable testing. Cardiorespiratory fitness is one of the strongest health-related functional measures we have. And unlike chronological age, it can change substantially. That's the part worth paying attention to. Not whether an app tells you your biological age changed from 47.8 to 44.2 after 3 weeks. Whether your actual organism became more capable. Can your heart move more oxygen? Can your muscles use it? Can you produce more force? Can you recover from stress? Can you control glucose effectively? Can you maintain those abilities into older age? That's functional youth. And it's much harder to fake than a number on a dashboard. Where most people get this wrong, there are 3 mistakes I see repeatedly. Mistake 1. Doing the hard part and skipping the boring part. Intervals feel productive. Supplements feel advanced. Cold plunges feel dramatic. Going to bed at the same time every night does not. Walking after dinner does not. 35 minutes on a stationary bike at moderate intensity does not. But biology doesn't care which intervention looks impressive on social media. It responds to signals. Mistake 2. Trying to change everything in 1 week. You begin Zone 2. Strength training. Intervals. Fasting. A completely different diet. Morning light. No alcohol. 8 supplements. And a new bedtime. That works beautifully for approximately 5 days. Then, life happens. A sustainable system compounds. An unsustainable system resets. Start with the highest return missing behavior. If you don't exercise, start walking and build aerobic fitness. If you train but sleep 5 hours, fix sleep. If you already train and sleep well, add structured Zone 2. Then strength. Then a small amount of intensity. Build the stack. Don't explode into it. Mistake 3. Thinking mitochondrial health is something you feel immediately. Sometimes you do feel different. Often you don't. Mitochondrial biogenesis is not a stimulant. Mitophagy doesn't create a tingling sensation. Improved oxidative capacity isn't supposed to give you a buzz. The adaptations reveal themselves in what your body can do. This matters because the health industry has trained people to judge interventions by immediate sensation. Take something. Feel something. Therefore, it must be working. Biology is rarely that convenient. The boring adaptations are often the important ones. They happen quietly. Then 6 months later, the staircase that used to make you breathe hard doesn't. That's the result. The bigger picture. Now let's zoom out. Because mitochondrial repair is not really about mitochondria. It's about what mitochondria allow the rest of your body to keep doing. Your brain needs enormous amounts of energy. Your heart never stops contracting. Your muscles determine whether you're independent at 80. Your immune system requires energy. Tissue repair requires energy. Protein synthesis requires energy. Everything we call vitality eventually has an energetic cost, and aging gradually narrows your reserve. A young body can often absorb a bad night of sleep, a period of inactivity, a metabolic insult, an infection. An older body usually has less margin. So the goal is not to make yourself biologically 20 again. It's to preserve and rebuild reserve, more aerobic capacity, more strength, better glucose control, more efficient energy production, better recovery, a larger buffer between what ordinary life demands and the maximum your body can produce. That's why a fit 70-year-old can sometimes function more like an average person decades younger. Their chronological age didn't reverse. Their capacity tells a different story, and mitochondria are deeply involved in that story. Here's what I want to make clear before we finish. Nothing in this protocol should be interpreted as a treatment for mitochondrial disease, chronic fatigue, unexplained exercise intolerance, heart disease, or any other medical condition. Those require proper medical evaluation, and none of this proves that you can literally reverse human aging by repairing mitochondria. That's too strong. What the evidence does support is much more useful. Mitochondrial function remains adaptable across adulthood. Exercise can increase mitochondrial capacity. Muscle can be rebuilt. Cardiorespiratory fitness can improve. Insulin sensitivity can improve. Sleep can improve. And many biological systems that tend to decline with age are still responsive to the signals you send them. That's not immortality. It's plasticity, and plasticity is enough to change the trajectory. So if you remember nothing else from this video, remember the sequence. First, stop looking for a mitochondrial booster. Improve mitochondrial quality. Second, build your aerobic base. Third, add a small dose of intensity. Fourth, protect your muscle with resistance training. Fifth, protect sleep and circadian timing. Sixth, build metabolic flexibility through movement, sensible meal timing, and a minimally processed diet. Then recover, repeat, and let the signals compound. Not for 7 days, not for one 30-day challenge, for years. Because your mitochondria are constantly responding to the environment you create for them, the question is whether that environment keeps telling them to deteriorate or gives them a reason to adapt. If this changed how you think about aging, share it with someone who needs to hear it. Subscribe for more content like this. The mechanisms, the researcher, the things that actually matter. And in the next video, we're going one level deeper into mitophagy, how your cells decide which mitochondria are damaged, how they remove them, and why that cleanup system appears to weaken as you age. Because building new mitochondria is only half the equation, you also have to know how to clear the broken ones. See you in the next one.